Okay, so I want to go over, finish up what we were talking about with inverses today. Sorry I can't be there. Uh, Having my doctor's appointment with the wife here, so she can't drive, so taking her to that. Um, so what we were talking about last time with inverses is if we have an inverse. Okay, here's the notation for finding the inverse. If we have a function, I should say, we want to find the inverse, right? We could do it one of two ways. We said that we could just look at this and say, well, if we want to find f of, say, 5, right, we would take 2 times 5, so we would multiply first by 5, and then we would add 3. Well, an inverse is just going to be the opposite of those operations and in the reverse order. So then the inverse, we would take x, and we would subtract 3, because that's the last thing we did here, and then divide by 5, right? And that works in pretty simplified cases, but there are definitely some where that's just not going to work very well for us. So if we wanted to do it in a different way, like you were shown last year, then you would switch the x's and y's. And why do we switch the x's and y's? Well, because as we learned, in an inverse and a function, the domains and the range switch. It's a reflection, right? Remember that the graphs is a reflection of the y equals x line. And when it's a reflection, you're switching the x's and y's around. You might remember that in a reflection, if you look in the mirror, for example, you hold up your right hand, it's the left hand that you see, right? Or the left side anyway. The orientation changes. So the same principle is here. When the domain and range are going to switch. It's the same idea. So now we're just going to solve for y. And divide by 2. And see, we get the same thing. So anyhow, that's kind of where we left off when we were finding an inverse. All right. Now, I wanted you to get to the Chromebooks because I wanted you to go to the website and pull off this file called function inverse, which looks like this. So I'll go ahead and we'll pause this until you get there. All right. Okay, so once you're there, right, we have a parabola, okay, y equals x squared, and we have the reflection line, and then we have the inverse of it, right? So if I look at this inverse, I can change it to make it look a little different by changing the domain. All right. Now, let's do this. Let's take the vertical line test. That's this button here. And look at the green one. So is the green one a function? Obvious answer is no, because it crosses in 2 spots, right? Well, what we have to do then is we have to change the original function so that when we graph the inverse, then the inverse is a function. Well, how do we do that? Well, let's take this slider and change it so that we don't have an issue, right? So something like that. Now if we apply the vertical line test, aha, we're all set, okay? So what we did is we took the original function here and we split it. We changed the domain so that now the inverse works, okay? So when, in certain cases, you're going to have some functions. And when you find their inverses will not be functions unless we restrict the domain, all right? So, for example, let's say we have something like this, okay? That's another parabola. So, if I graph it, it's going to look like that, all right? We want to find the inverse. And yes, we could probably do it the simplified way, right? Because we know that if I knew, like if I wanted to find f of 3, I would square first and subtract 2. Square, subtract 2. So in this case, I'm going to take my x, go in the reverse order. I would add 2, and then I have to think, well, what is the opposite or the inverse of squaring? Well, that would be square rooting. Correct? So that should be what the inverse looks like. So if I graph that, all right, I'm going to put it in a little different color. I'm going to get something that looks like this. Okay. And if I overlay that kind of with the one I have, I get this. Now, the square root is just a half a part, right? But remember that you can always take the plus or minus of the square root when you're solving things, okay? Problem is, that makes it not a function. So that's why we have to restrict the domain. I didn't want to get rid of the whole darn thing, but so we have to restrict the domain. Okay. So if we wipe out all the way to here, we just take that part out, we'll be in good shape. We can demonstrate that with this. Okay. Let me take the take that back. All right, there it is. Right. Reflect. There it is. Okay. There's my square root. Whoops, can't have that. We got to restrict it. Okay, so I'm going to grab this. And you can do it at the same time so you can follow along with me. You're probably grabbing it better than I am with my pen's not seeming to be working very well. Now, nothing seems to be working very well. Just going to refresh it. There we go. Reflect. There we go. Maybe I can grab this now. No, it's still not letting me grab it very well. I don't know why. Hopefully you're getting able to move it. So then we want to restrict it anyway so that we only come down to here. And that way that inverse will transfer over to this side and we'll get it to work. Okay. There it goes. I finally kind of got it to work. Right. There we go. All right, and the vertical line test all passes. So it's good. All right, so that works out okay. So what do we have to do? Well, when we find the inverse here, we have to say here that we're going to restrict the domain so that x values are greater than or equal to 0, right? And the range values here are greater than or equal to -2, all right? So now my domain and my range are going to switch, right? So, the range becomes this, greater than or equal to -2, and this is going to be y is greater than or equal to 0. Oh, well, that's what we want, because that keeps this thing above the x-axis, which means it won't be a function, okay? That's what that range is. So that worked out okay for me, all right? So I just have to make sure that I keep this in mind. The domain and range are going to switch, and I'm going to keep this domain right to there, okay? All right, so let's take a look at some other functions. Let's try something like this, right? Now we know what this is going to be a rational function, okay? And we know right away that this can't happen, right? At least we should, correct? All right. And my range, if I'm not sure, we can go ahead and graph it and take a look at it. Okay, we're going to find the inverse. Now, can we do this by just looking at it and kind of figuring it out? Well, perhaps, but it's a little bit trickier with rationals. So let's take this approach. Okay, switch the domain and range. Now we got to solve for y. Well, I'm going to do this. Okay, I'm going to do some cross multiplication here. All right. I still got to solve for y. Well, I have this x thing here, and I think what I'm going to do is move it inside. Right, and now I'm going to subtract a 2x from both sides. And then divide by x. And there's my inverse. Okay, so I think this way is probably better when you have a little more complicated function you want to find the inverse of. It's a little trickier doing it by just kind of looking at an examination, right? Okay, so let's see what GeoGebra does with this. I don't know if we'll be able to pull this off, but let's give it a try. So let's see. I have to go back and try to remember what it was that I did. 4 over x plus 2. So I'm going to go 4 over x plus 2. Says I need to check my input. Okay, I'm trying. Okay, I got it to work. So here is the 4 over x plus 2. Here's the inverse. Sort of looks like a vertical line test is going to be okay, right? If I go along here. Now I know there's more graph down here. I just can't see it. I don't know if it will let me zoom out or not. It's not cooperating a whole lot. Oof, there we go. Maybe that wasn't such a good idea. I think I'm going to go back to the regular screen. They're pretty slow. Anyhow, we can see that the inverse looks okay. All right. There we go. I don't know what's going on now, folks. There we go. Anyhow, I can see it looks like the inverse is okay, right? And it's kind of interesting because they almost look in the same thing, all right? So let's go back to this. Here's the domain and range, right? Here, the domain and range. Well, they switch. So then this range should become that domain. Look at that. And the range should be greater than or equal to 2. Now, I'm not going to use GeoGebra to graph it because that's obviously not working very well. So let's give Desmos a try. Okay, so y equals, now let me take a look at that inverse. 4 minus 2x over x. There it is. So it has to be, let's see, we're talking about, we want something greater than -2. Now, -2 line is right here. Let me graph that in there so you can see it. Y equals -2. Put that in there, and we can see, yeah, that's just going to stay right above that, or below. It's never going to touch it. So, hey, how about that? They're switching, okay? And that's allowing us to restrict the domain. All right. Now, so we did that, okay? The next question is, how do we know by the graph of a function if we need to restrict a domain? Or how do we know if its function is going to be an inverse or a relation? Well, let's go back to this guy, right? And I'm going to change this back to the x squared again. I think I'm just going to refresh it, actually. There's that, right? Got this. I have the green function. There's something on here called the horizontal line test. Well, what does that do? Well, here, notice that the horizontal line test touches this in 2 spots. So as we slide the horizontal line test, okay, and it touches in 2 spots, then we can see that this function's not going to have an inverse. Unless, of course, somehow the domain is restricted, right? Okay, same kind of idea. So the horizontal line test gives us a sense for that. So horizontal line test on the graph of a function. Same as a vertical. If the horizontal line touches graph in more than one spot, the inverse is not a function. All right. Okay. Now, in more advanced mathematics, if you took a course on functional analysis and they dealt strictly with functions and inverses and their operations and the whole bit, here's what they would say. Let's say that we have something like this. Okay. We say this function is 1 to 1. Why? Because for each x, there's one y, right? 1 to 1. Remember that in this case, we said this was a function, right? Because even though they're going to the same number, it's still one element in the range paired with one element in the domain, right? It's just going to one deal. But this function is not 1 to 1. Because this one guy is going to the same, these are all going to the same y element. They're not different. Okay, so then we would say this one is not 1 to 1, but this one is 1 to 1. Okay, so that's basically what the horizontal line test is saying. That doesn't work. Okay, so just wanted to point that out to you. All right. One other thing I noticed I didn't get to cover here. Let's go back up to one of our functions that was, we could do this one, x squared minus 2x squared root of x plus 2. Okay. One definition of an inverse says that if you take the composition of the inverse and its function, you should get the identity. And that was something that we mentioned before. So let's do that. So let's say we take this thing here, right? Put it in there. See what we get. So we're going to take square root of x plus 2 squared and then subtract 2. Well, that's just going to take care of the square root. And that's just going to give me x. So it works that way, right? Well, it has to work in both orders. In other words, we have to have f of f inverse and f inverse of f in order for it to work. So now I'm going to take this x squared minus 2 and put it in there. 2 minus 2, gone. Square root of x squared is x. So thus it works. All right. So I'm looking at some of the problems here, and on page 135, talks about if the relation is a function, does the relation have an inverse? You should be able to do those. Finding formulas, including any restrictions. Again, we did all those problems. You should be okay with that. One-to-one, we talked about that. And then confirming that f and g are inverses by showing that f of g and g of f. So that's where you would do this, okay, on those. Just going to kind of put them inside there, okay. So I think we got everything covered. Test reviews, test is Thursday. It will cover everything up to what we just did now. So there will not be anything from tomorrow on the test, which is going to be, so we're going to start doing some transformations. That will not be on it, but inverses will. Anything else that we've done so far will. The review is not an assignment. It's just a guide. Okay, nothing more than that. Chapter problem, which I was supposed to give you last week, forgot. Giving it to you today, and it's due on the 11th, I think it is, of October, which should be a Thursday of next week, because we have Friday off. All right, so just want to make sure we got that. Other than that, that should be it, and we'll see you tomorrow.